Human history is basically a list of things that couldn't be done and then were done. About 1.5 years ago, I stood on a similar stage in my hometown of Delft, the Netherlands. There, I presented my idea on how to clean the oceans of plastic. I talked about how, while diving in Greece, I came across more plastic bags than fish. I talked about my high school science project, which I used to study the problem itself and why it's so difficult to clean up. It amazed me that in the middle of the oceans, over 1,000 miles offshore, in a place where perhaps no human has ever been, you can find 6 times more plastic than plankton. It amazed me that over 100,000 mammals and over 1 million seabirds die each year because of that same plastic. It absolutely shocked me that entire species are being threatened by it. But what perhaps astounded me even more was that most people involved in the topic were absolutely certain a cleanup would be impossible, even though nobody has ever seriously investigated it. It is, of course, essential to first close the tap to prevent any more plastic from reaching the oceans in the first place. But that is not a solution to the plastics already trapped in the currents of the gyres. If feasible, a cleanup technique could greatly reduce the economic, ecological, and health impact in those regions. Besides, the natural plastic loss from these concentration areas is likely small, so it hardly goes away by itself. A massive challenge it will be, though. The name Great Pacific Garbage Patch suggests there will be an island of trash floating in the middle of the oceans. And this image has spurred many cleanup concepts, all of them being based on vessels with nets that will be fishing for plastic. Unfortunately, though, even though the concentration of plastics is extremely high compared to the rest of the oceans in these 5 subtropical gyres, it's still spread out over millions of square kilometers. And hence, it would likely take many billions of dollars and thousands of years to clean up a gyre using such methods. Besides, bycatch and emissions would likely cancel out the good work. And furthermore, the oceans aren't a particularly friendly place to do things. However, I realized back in high school there might be an alternative. I wondered, why move through the oceans if the oceans can move through you? Instead of going after the plastics, you could simply wait for the plastic to come to you without requiring any added energy. An array of floating barriers would first catch and then concentrate the debris, enabling a platform to efficiently extract the plastic afterwards. The ocean current would pass underneath these barriers, taking all neutrally buoyant sea life with it, preventing bycatch. An elegant idea. But when I got asked to present this idea at a TEDx Delft conference, it wasn't much more than that, an idea. But I reckoned it was an idea worth spreading. So I then started studying aerospace engineering, but I really couldn't stop thinking about it. A bit like one of those boxer shorts with an asymmetrically positioned label in them. It's very annoying. So I then turned to some professors and industry experts with whom I compiled a list of 50 questions that should be answered in order to call my idea a feasible solution. But when I attempted to start answering those questions, things didn't really go according to plan. The only budget available at the time was the 200 euros of pocket money I saved up, and there were only a couple of people that offered their help back then. So, realizing this project was going nowhere, I recall when on one day I contacted about 300 companies for sponsorship. Only one replied, and that one too resulted in a dead end. I wasn't prepared to give up though, and decided to pause both university and social life in order to focus all my time on this idea. So I set up a foundation, the ocean cleanup. But those 50 question marks remained untouched, which bothered me. But then something peculiar happened, and it changed my life. The 26th of March 2013 started out like any other day, but soon my phone wouldn't stop ringing, the ocean cleanup social media exploded, and for days I received over 1,500 emails per day in my personal mailbox. The story went viral. So we then started a crowdfunding campaign and reached the $80,000 target in 15 days. And using all the offers to help, we then assembled a team, which eventually grew to about 100 volunteers and professionals. Here you can see part of our team in Delft. Suddenly, I wasn't alone anymore. So we also received a lot of questions that fortunately confirmed the 50 questions we set out to answer were the right ones. So now we had the budget and the people to perform an extensive feasibility study. The 50 questions covered the fields of engineering, oceanography, ecology, maritime law, finance, and recycling. It took us a year, but finally it's here. All 530 pages of it. It can't be done because the collected plastic is too deep. Well, so we built this multi-level troll, organized several expeditions to Ajaya, and measured the vertical distribution of plastics. And what we found was that, depending on the weather, fortunately, most plastics can be found in the top 3 meters. It can't be done because of the storms. So, while using computer simulations and scale model tests, we then engineered a floating barrier that can survive in over 95% of conditions. And if waves get even higher than that, the booms would be decoupled on one side to let them move with the waves, keeping them in one piece. It can't be done because booms don't work. So, for this system to work, 2 basic principles still had to be proven. First of all, plastic would need to be captured by these floating barriers, and secondly, the plastic would need to travel along the angled barriers. So we simulated the flow around these booms, which showed us it actually works. But even better, we then built a 40-meter-long boom as a proof of concept and deployed it in the Atlantic near the Azores, which confirmed the results. It can't be done because it's impossible to anchor something that deep. While working together with world experts in this field, it actually turns out there's not a lot of difference compared to a mooring system at, for example, 2.5 kilometers of depth. And because positioning doesn't have to be as precise as with, for example, oil drilling, it turns out we can actually use quite a simple mooring design. it can't be done because it would damage the environment. For this project to be worthwhile, the environmental impact should, of course, be absolutely negligible. And even though the plastic or the plankton would likely be safely taken away by the current, even if all plankton encountering these barriers would be damaged, the time it would take to restore the biomass is less than 7 seconds in a year. And in terms of fish and mammals, any impact seems unlikely because no nets are used. Entanglement is virtually impossible. And finally, the carbon footprint was calculated to be equal to only several hundred cars, making that negligible as well. It can't be done because the collected plastics would be useless. So we collected about 0.5 ton of plastics from the Hawaiian shoreline for research. And first, we proved ocean plastic can be turned into oil and is just as suitable as normal waste plastic. The details of which can, of course, be read in our feasibility study. But look closer at the report itself, and you can actually see that the book's cover has been made from plastic that has circled the oceans from years to decades. It couldn't be done, but based on all the research, we haven't found a single reason it cannot be done. We can only conclude that it could be done. It's feasible. Thank you. Using a single 100-kilometer array, deployed it for 10 years, almost half the plastic within the North Pacific garbage patch can be removed. And it would cost only about $6 per kilo. That's about 33 times cheaper than conventional methods. This is it. The largest structure ever deployed on the oceans by 2 orders of magnitude. On either side of the platform, there will be over 50 kilometers of floating barrier. And what you can see here is only 2 kilometers, just to give you a sense of scale. And the plastic traveling along these floating barriers will get increasingly more concentrated. And arriving here at the center, it will be so dense you can hardly see the water. And now prepare yourself for quite a radical change, because this is the new platform. And although it might not look as graceful as some of the early concept designs, this no-nonsense structure is stable, cost-effective, and storm-resistant. In terms of the extraction equipment, existing technologies turned out to be suitable. A slurry pump coupled to a centrifuge will be able to extract the smaller particles, while a mesh conveyor like this one will be able to scoop out the larger debris. Moving to the top deck, you can see 162 solar panels, which is sufficient to act as the primary power supplier for the platform. We have now successfully proven the feasibility of this concept, and I would like to thank every single one of you, the engineers, the volunteers, the funders, the sponsors, and the supporters for their help in completing this essential first step. But we are not there yet. Until I can look over the bow of a ship and see the awesome sight of the ocean cleanup array around me, I vow to continue with this project. Now, it's time for the second phase. Through a series of upscaling tests, we'll now work towards a large-scale and fully operational pilot in 3 to 4 years' time. And to do it, we need your help. We need companies to help further develop the concept. We need institutes to help do more research. And we need individuals for their help and for spreading the word. And to help fund this major next step of the project, I can hereby announce the start of a new crowdfunding campaign that is now live on theoceancleanup.com. And I need your help to make the ocean cleanup one of those things that couldn't be done, but then we're done. Thank you very much. Thank you.